Unit 2B, Lesson 1, Function Notation. The main idea of this lesson is to understand what a relation is and understand what a function is. We'll also want to be able to identify functions, whether we're given ordered pairs or graphs. So to start out, we need to define some terms. First, relations. And in their most basic form, a relation is simply a set of ordered pairs. There's no rule that we have to follow with the values of those ordered pairs. We just have x and y coordinates. We could plot those points on the coordinate plane. That represents a relation. A function is a set of ordered pairs such that every input has exactly one output. So a function is a type of relation with that condition in place. Every input has exactly one output. So some key ideas: every function is also going to be a relation, but not every relation has to be a function. Now to the first examples, we want to determine if the relation is a function. So we have our x values, these are the inputs. We have our y values, these are the outputs. Recall the definition for a function. It's a set of ordered pairs such that every input has exactly one output. So we have our input of 0. That single input is going to 4 different outputs. The input of 0 goes to 0, 1, 2, and 3. So our single input goes to 4 different outputs. That does not satisfy the condition or the definition we had for a function. So this would be no. This set of ordered pairs, this relation, does not satisfy the condition to be a function. Now we go to the next one. We have our inputs, our x values, 1, 2, 3, 4. Then we have our outputs, the y values, 3, 6, 9, 12. The input of 1 goes to 3. The input of 2 goes to 6. 3 goes to 9. And 4 goes to 12. So each input goes to exactly one output value. That meets our condition for that relation to be a function, so that would be yes. Now to the next example, using a similar idea, we want to determine which relation is a function. Look at our input values. Does every input go to exactly one output? If we look at our first one, we have 4 different inputs. They each go to exactly one output. So right away we can see the correct choice is going to be A. When we look at B, C, and D, quickly analyze why those ones are not going to be functions. If we look at the input of 3, that single input of 3 goes to 2 different outputs. 3 corresponds to 4, and 3 corresponds to 5. So we have a single input corresponding to 2 outputs, does not meet our definition. C, we have a single input corresponding to 4 different outputs. And in D, we have a single input 3 corresponding to 2 outputs, and also 1, that single input, is corresponding to 2 outputs as well. Every input has to correspond to exactly one output for that relation to be a function. In this example, we want to again determine which of the following is a function. It's the same idea as before, they're just using a different notation for us to analyze. So when looking at these notations, each of these sets of parentheses represents our xy ordered pair. So in part B, we have our input, which would be negative A. We have our output, the y value, negative 3. So we have to determine, go through the same idea, make sure every input corresponds to exactly one output. Right away, we can see A is not going to work because this doesn't even have ordered pairs. It just has a set of numbers. They're not ordered pairs, so A is not going to work at all. We can skip that right away. Now for B, we have negative 8 as an input, we have negative 3 as an input, and we have negative 8 as an output, or an input, excuse me. So we have that input of negative 8 corresponding to 2 different outputs, 2 different y values, so that can't be a function. Part C, we have negative 8, negative 5, and 7 for the inputs. the input of -5 is repeated, it corresponds to two different outputs. That can't be a function. Part D, we have -8, -3, 7. None of our inputs are repeated. Each input corresponds to exactly one output, so the correct choice would have to be D. So far, we've looked at ordered pairs or tables of values to determine whether the given relation is a function. To end the lesson, we're going to talk about how to look at the graphs of a relation and determine whether or not that relation is a function. And what we're going to use is the vertical line test. That's going to allow us to determine if a relation, the graph of a relation, is a function. So essentially all we're going to do is construct a vertical line anywhere through the graph of the relation. If it intersects at only or at most one point, then the relation is going to be a function. If we construct a vertical line and it intersects the graph at more than one point, then the relation is not going to be a function. Now to the last example, we want to use the vertical line test to determine if the graph of the relation represents a function. So in the first one, we have this wave. This graph actually represents the graph of a trig function. We'll talk about that more in geometry and algebra 2. So what we want to do to use the vertical line test, if we would construct a vertical line anywhere through the graph of this relation, it is only going to intersect that graph at most one point. So if that's the case, then this is going to be yes. This relation is a function. If we go to the second one, same idea. If we construct a vertical line anywhere through the graph of this relation, it is going to only intersect in at most one point. So again, this would be yes. This relation is a function. To the third one, we can see that if I construct a vertical line through that point, that x value of around -5, we're going to get two different y values. So for that single input, we have two different outputs, so that is going to be no. That does not pass the vertical line test. That relation is not going to be a function. And then the fourth one, this is very similar to the second one, except we have an overlap of the graph. If I would construct a vertical line, that is going to intersect the graph at 2 points. So for the single input of x equals 2, we have two different outputs, so that would be no. So using the vertical line test, you construct a vertical line. If at any vertical line you intersect the graph in more than one point, then that is not going to be a function.